Hello and welcome back to our assembly programming language tutorial. We already introduced the basics of the assembly language in the first video. You can check it from the link below. Now we are going to write our first program with assembly. It is going to be just a simple calculator using assembly language. First of all, we need to add some messages which we are going to use throughout the program. So let's start. First, we'll create a new file the same way we created a file in the previous video and start writing your program. Okay, first of all, we will add our first message, and in this message we will write what's supposed to be appeared for him while he's choosing the operation he needs to do. So this 0D0H and 0A0H represent that he enters and he goes to a new line and starts from the first of the line. Now we have add and we have multiply. And we have subtract. And finally we have divide. And this is number 4. And enter a new line so that the user will write in it the input, and then finally our $sign. This is the first message. Then we have also another message. I can name it, for example, message 1, message 2, and we have db. We start by the new line, and this message will be enter first number and our $sign. Then we have message 3 will be enter second number, and we have also a choice error. If he choose something, expect 1 or 2 and 3 or 4 if he input something else. So this is a choice error. And we have also, we just need to change the names and a message for the result. And finally the message which will appear after he finished using the calculator. It may be, for example, thank you for using a calculator. And press any key to exit. Okay, now we finished our messages. Now here I'm gonna say jump start, and here we're going to add a new tag start. So the first thing we need to do is to give him the first message, which is add, multiply, subtract, divide, so he can choose the operation he needs to do. So first of all, we'll use interrupt 21h to display our message. So I'll move into AH9 and move to DX our message, which is name is message, offset and message, and then interrupt 21h, and then we will move. We now have our output. Now we need an input from the user. We need to know what he chose. He entered 1, 2, 3 or 4. So we're going to use interrupt 16h to read the key press. So we're going to move AH and 0 and interrupt 16h. So now we have the key press. We need to know if this key press is 1, so we're going to go for a procedure for the addition, or 2, so we're going to go for a procedure for the multiply, and 3 a procedure for the subtract, and 4 a procedure for the division. So the value of the input will be stored in AL, as we previously said in the previous video. So we're going to compare this value in AL with 31, which represents 1 in ASCII, and if it's equal to 1, we'll jump equal to addition, which is the procedure of the addition, and then we'll compare this AL to 32h. This means that the key press is 2. 32h is the ASCII value of 2, so jump equal to multiply, and if it's 33 means subtract, and finally 34 is divide. Okay, and if he wrote, if the value of AL is not 1 and not 2 and not 3 and not 4, this means we have a choice error. So we need to output for him this message, choice error, which is message 4. So we'll do this using interrupt 21h and move AH and 9 and move DX and offset message 4 and interrupt 21h. Then we move AH and 0 and interrupt 16. So when he press any key, we'll jump back to start, so he can choose another operation, or he can write a number which is valid, a number between 1 and 4. So now let's add our tags. First we have addition tag, and we have multiply tag, and subtract, and divide. Let's try this and see if everything will work as we expect. Let's move it step by step. We'll jump to start, move AH 9 and move into DX the value of the message. Move AH 9 and move into DX the value of the message, and then interrupt 21h. So here's our message. Now we need to take an input from the user. So interrupt 16h. So now we want to give an input. For example, if we said 5, so he compared it. The value of AL would be 35. He will compare it if it's 1, 2, and 3 or 4. He'll check. And if it's not all of this, so he will give us the message choice error. And he's now waiting for a key to restart, so we can choose, or we can press another key which is valid. We press enter, and then he will jump back to the first and wait for another input. Okay, so here is it. Now let's work on the procedure for addition. The first thing we need to do is to give an output for the user to this message, enter first number. So I'm gonna move AH 9, and I think 09H, and then move DX and offset message. This is message 2, and interrupt 21H. So now we have our message on the screen. Now we need to take an input from the user, which is our first number. So to do this, we're going to create a new procedure, input number, to handle this. And we'll call it from here. So we'll call input number. But before this, we need to move here CX and 0, because this CX will represent the counter of the digits in this number. For example, if the input was 2, 3, and 4, so we have here 3 digits. This counter will be stored in CX. We will handle this later on in our procedure. Call input number. So now let's create our input number procedure. Okay, in this input number, we need to take first an input from the user. So we'll use interrupt 16. We'll take this input. Now we have the input stored in AL. We need first to compare if this input is enter, and this means that he finished and he entered his number. If it's not enter, then it means that he's still entering the number. We will take each number separately. We'll take 2 to be stored in AL, and then we will add it to the stack, and then we will take another input. If he pressed enter, then we finish. We have also only the 2. If he entered another number, we will also take it, add it to the stack until he press enter. And if he press enter, we will call another procedure, which is for number, which we will write later on after we finish writing this procedure. But first of all, we need to subtract from AX 30H to convert the value stored in AL from ASCII to decimal, and then call a procedure view number. This procedure will just view the key pressed on the screen. Let's write this procedure view number. Suppose that this procedure expect that the value he will output on the screen is stored in AX as it in our case. So first, because we will change the values of AX and DX, and we need to use them later on after we return from the call, so we are going to push the current values to the stack, and we will pop them back after we finish and we output the message or the number, to the user on the screen. So first we'll move DX AX, we'll put the content of AX into DX. As the interrupt 21H, expect that the output that he will give to the user on the screen is stored in DX, and we will add to DL 30H to convert it back to ASCII, so he can understand the number and output on the screen. You may wonder why we already converted from decimal to ASCII. We do this in the first procedure because we're going to use this decimal number later on in this procedure. But in the view, he needed an ASCII, so I converted back. Move AH and 2 and interrupt 21H. See, here's the difference between when you are viewing a message, we move into AH9, and here we are viewing a number or the value of a register, so we move to AH2. And every case had a number. Move AH and 2 and then interrupt 21H, and then pop back the DX and AX. Just make sure that you pop back what you added to the last value added to the stack is the first value to be popped back when you pop from the stack. Make sure that you understand this. So here we finish the procedure. View number. Let's come back to our input number. We call view number, and now we view the number on the screen. So we need to push the value of AX into the stack and increment the value of CX, which is the counter, and jump back to input number from the beginning to take another input until the value is enter. We'll jump into form number. So we move AH and 0 and push AX and increment CX and jump back into input number. So now we finished the input number procedure. We entered, for example, 2. He will go back here and take another input, compare it if it's enter. So now we finished. So we'll jump into the form number procedure. Let's write this form number procedure. Just give ourselves a space. Okay, in this form number, we will take the values in the stack, and we'll just need to do some work on them to add our number in 1 byte, as we took each number separately. For example, we took first 2 and then 3 and then 4. Each number is stored in a stack separately. We need to add them and store it in 1 byte. But to do this, we'll first work on the first number, which is 4. This is the unit, so we'll multiply this by 1 and add it to 0. It will be 4 multiply 1 and plus 0. This is equal to 4. Then we'll work on this 3. We'll multiply, this is the tens, so we'll multiply this to 10 and add it to the 4, which is the initial value. It will be equal to 34. And then we have the 2. It's the hundreds, so multiply this into 100 and add it to the 34. So we'll have our number 234 and we'll store it into 1 byte. Let's see how are we going to do this. First of all, we will take the first value in the stack, which is the last value added to the stack. It's not the 2, it will be the 4, the last value added. So we'll pop back AX, and we need to add here, before form number, we need to add to move BX and 1, which is the initial value. The first number will be multiplied by 1, and then 10, and then 100, and then 1000. And we need also to move DX and 0, which is the initial, the register which we will add on the values at each iteration. So we'll pop AX, and before we do the multiply, we need to push the value of DX to the stack and then multiply BX. Here he multiply the value of BX to AX, which is 1, and the value of AX, which is the input of the user. For example, if it's 4, it's 4 multiply 1, and he will return the value back in AX and DX. So the DX is affected by the multiplication process, so we need to push it to the stack because we need the value in it to work. We will use it later on and pop it back after we finish the multiplication process. And then we will add this DX to AX, which is the result of the multiplication. At the first input, this DX still contains 0, but after we add to it the 4, if our number is 234, now this DX contains 4. At the second iteration, we need this 4 to add it to 30, which will be the value in AX after the multiplication of 3 and 10. We'll see how we're going to do this. After we add DX and AX, we'll now move AX and BX. We'll take the value in BX and move to BX and 10 and multiply BX. This will multiply the value of BX by 10. If it's 1, it will be 10. As this is the value, we need to multiply it to the second number, which is 3. But before the multiply, we need just also here to push DX to the stack and pop it back after the process, so it won't be affected. And we will move the new value. The result of this multiplication is stored in AX, so we need to move it back to BX. So when we jump back to the start of form number, expect that the value of the multiplication will be in BX. So I move it back to BX, and my decrement from CX, we finish the first number. CX represents the counter of digits, so we finish the first. We still have 2 numbers left, so we'll do 3 minus 1, and the value of CX will be 2. And then we will compare the value of CX. If it's equal to 0, this means we finished. We worked on all the digits. So jump not equal to 0 to form number, to the start of form number if it's not equal to 0, and if it equal to 0, we will return. So here that we finished this procedure, he will first take the 4 and here he multiply it to 1, which is the initial value of Vx, and then he multiply Vx by 10, so the value of Vx would be 10, and decrement the value of Cx minus 1, it will be 2, compared to 0, it won't be 0, so he'll jump back to form number. After he jump back to form number, I will take the second value in the stack, which is 3, and the new value of Vx is 10. He multiply Bx and Ex, so the result will be 30. He will add it to Dx, which is now 4, not 0. It is the value of the previous addition. We will add 30 and 4. Now we have 34. Then we multiply this Bx by 10 again. It will be 100, and then do the same and decrement Cx. It will be 1. Move back. Multiply this 2, which is the last value in the stack, by 100, and it will be 200. We will add it to the value in Dx, which is now 34. We will have 234. We will do this if we are here expecting that we have another value. We will compare that decrement Cx. If it's 0, so now we will return back to the addition procedure. After we return back to the addition procedure, now we have our first number stored in Dx. So we want now to take the second numbers. First we will push this Dx to the stack, as it will be affected when we are forming the second number, and after we push it to the stack, we will output the second message, which is enter second number, which is message 3. Okay, and we are here. Move Dx and offset message 3 and interrupt 21H. We'll do the same. We will use the same procedure to get the number, and it also come back in Dx. We'll use the same procedures. After we viewed the message, we will move also Cx and 0 before we call input number, and then call input number, which will handle the operation the same way as we handled our first number. Then we'll pop back the value, this Dx, which is the value of the first number, into Bx, and add the two numbers Dx and Bx. Now we have our result stored in Dx. We will push Dx to the stack, as we need to view another message, so it won't be affected. And we move EH and 9 and move Dx. We now need to view this message, which is result equal to whatever, which is the value in Dx. So here move Dx and offset message 5 and interrupt 21H. Then we viewed our message. We'll pop back the Dx. Then we need to view our result on the screen. We viewed the message and we need to view the number beside the message. So first we'll move into Cx 1000, which represents the maximum number which this calculator can calculate. And we'll call a procedure view. Let's write this procedure. You can write it here. In this procedure, we want to view the result, which is stored in dx. So first we'll move ax into dx, and to do this, for example, if our result is 2, 3, and 4, and the maximum number that this calculator can calculate is 10,000. So we'll divide this 2, 3, and 4 into 10,000. We can't output this number at one time. We need to output each number separately. So we'll divide this. It will return, for example, at the first divide 0.00234. Okay, then we will divide this number by 10, so it will be 1000, and we will divide will be the result. Okay, then we will divide this number by 10, it will be 1000, and we will take this number and divide it again, and we will output this 0 on the screen until we output each number separately. When you see how we're going to do this, you will understand this more. First we move ax and dx, and move dx and 0. We need that the value of the division will be either in ax and dx, and if it is in ax, so the value of dx must be equal to 0, so there would be no confusion between the two numbers. So, and divide cx, which is 1/10,000. Now we have our value stored in ax and dx. The quotient is stored in ax, and the remainder is stored in dx. We already explained this in the previous video. So first we'll call view number. This view number expect that the number is stored in ax, so it will view the quotient of the first division, and then we need to divide this cx by 10 and do this over and over again until the cx is equal to 0. Now we output all the numbers. So we'll call view number, and then we need to divide the value of cx by 10. So first we'll move ax and cx, and move cx and 10, and divide cx. Now we divided the value of cx by 10, and the result is stored in ax. So, and he expects that the result is stored in cx when we come back to the second iteration. So we'll move cx and ax, and after we move cx and ax, we'll compare if this ax is equal to 0. If it's not equal to 0, we'll jump back to view. If it's equal to 0, then we finished and we will return. But just here before the divide, I need us to make sure we did everything. Okay, we need to move dx and 0. And we need the value of the quotient stored, which is stored in dx. So before this, we move it into bx, and then after we finish the division, we will move it back into dx. here we have the value in dx, we have the value of the reminder, which is the value that we will work on, and divide it by the result of the division of the cx by 10. So when we move dx and 0, we will lose the value in dx. So I will move it first into bx before doing the division operation, so it won't be affected, and after we finish the division operation I will move it back into dx and move the result of division, which is stored in ax, into cx, and compare this ax. If it's equal to 0, then we will return. If it's not equal to 0, then we will return back to the start of the view procedure to view another number of the result. And we return back here. Now we finished everything related to the addition procedure, so we'll jump into exit. This exit procedure, we will view in this exit procedure the thank you message for using the calculator, and give him to press any number. So we'll move dx and offset message, and it's message number 6. Okay, message 6, and we will move AH and 9, and then interrupt 21H, then move AH and 0, interrupt 16H, and here press any key, they return back and exit the program. So now we finished handling the addition procedure. Let's first emulate and then see if this will work. Then we will we'll go back and work on the other procedures of multiplication, subtract, and divide. So let's emulate. We have a problem here, call view number. Okay, call view number. Okay, emulate. Okay, now everything is fine. We'll work single step. We'll first output the first message. So here it is. Then take an input from the user. I press 1 to the value stored in AL is 31, which is represent add. He will compare the value of AL with 31. If it's equal to 31, he will jump into the addition procedure. So here you can see the code. He jumped into the addition procedure, and then he will give us the first message, which is enter first number. Enter first number. Okay, then he will take an input from the user. So we'll use interrupt 16 and take this input. For example, I press 2. He will take the input. He will compare this EL with 0D H, which is the ASCII value of enter, but here it's 32, so he won't jump into form number. He will subtract from AX30, so now the value of AL is equal to 2, and he called view number to view the key pressed. We will view it using interrupt 21H. So here it is, the 2 I pressed, and pop back the values as we said, so no values will be affected. Then push this value of AX to the stack. now we have our first digit and increment cx. The number of digits is now 1, and jump back into input numbers to take another input. We will take another input, for example 3. So he will do the same. He will compare. It will be enter, subtract 30, and then view it. The same operation. And increment cx. Now the value of ax equal to 3, and he pushed it into the stack. We had our second number, and the value of cx is now 2, and jump back, take another input. The same. We have 2 and 3, then 4. The same way, and he will view it. Here's it 2, 3, 4, and return back and jump back into input to take another input. Then I press enter. So now the value in AL will be 0D. So when he compare here AL to 0D, so they are equal, so he'll jump into form number. He will take the first value in the stack, which is now 4. Now the value of dx is now 0, but we'll push it to the stack. It won't be affected, and multiply the value into the stack by bx, which is equal to 1. Multiply the 4 by the 1, and after we do our multiply, we'll pop back the dx. It's still equal to 0, and add the values of dx and ax, and it will be stored in dx. So now we have in dx the value 4. Now we're going to multiply this bx by 10. So now we have the value stored in AL is equal to 10. We'll move it into bx and decrement cx. Instead of 3, it will be 2. And compare this cx. If it's equal to 0, this means we finished. Now it's equal to 2, so we still have 2 digits. So we'll jump back into form number, take the second value in the stack, which is 3. Now the dx is equal to 4, so we're going to push it in the stack, so it won't be affected from the multiplication process, and multiply 3 now by 10, not by 1, because this represents the tens, the second number, and the result will be 30, which is 1e. dx was changed into 0. We need our value back, so we'll pop back into dx the value in the stack, which is 4, and add dx and ax. Now it's 22, which represent 34 in hexa. Then we multiply the value in bx by 10, but before the multiply process we need to push dx into the stack so it won't be affected. Multiply. Now it's 64, which represents 100 in hexa, and pop back our dx and move the result of multiplication, which is 64, which is 100, into bx. So when we come back to the third iteration and decrement cx, it will be 1. Compare it to 0, still not 0. Jump back to form number. So we'll take another value from the stack, which is 2, which is the last value, and the same way, but here we will multiply the 2 by 100. Okay, we'll pop back the value in the dx and add the 34 in the dx by the value of the multiplication, which is 200. Now we have our number stored in dx. Okay, we're going here to decrement cx. Now it's equal to 0, so he will compare, he will return back to the addition. Now we have our first number stored in dx. We'll push this dx into the stack so it won't be affected, and give him the message to enter the second number. So here, enter the second number. Now we'll take the input from the user, for example 2, and then the same procedure. We're going to use the same procedure we used. We will view the 2 used in the first number. He now is waiting for another input. I'll just press enter. We don't need to enter more than one number. Now we moved back to the addition procedure. We'll pop back the value of the stack into bx and add dx, which is the second number, to bx, which is the first number which was in the stack. Now we have our result stored in dx. We will push this dx into the stack because it will be affected, and give him the last message, which is the result is equal to, and then pop back the value of dx and move into cx 10,000, which is the maximum number this calculator can calculate, and call view to view our result. So we have our result stored in dx. We'll move it into ax and move into dx0 and divide our result by 10,000. So in the first division, the value of the quotient will be 0 and the value of the remainder will be EC. We'll call view number. We will view the value in the quotient, which is 0, and then come back and divide this 10,000 by 10 and store the result of the division into cx and compare it. If it's equal to 0, then return. If it's not, jump back to view. So now we will divide the value, the new value, which is the quotient of the first division, but now not by 10,000, by only 1,000. Also the result of this division will be 0, the quotient will be 0 and the remainder will be EC. So we'll now view the 0 and then come back and divide. Now we have our first number, the value of the first number, 2, at the third division. We will also move in the same procedure. We have 2 and then we are now viewing our result. Okay, I'm going to move into the procedure. Now ax is equal to 0, so he will return, he finished, and he will jump into exit and give you the thank you message for using the calculator. So the result will be 236, the result of the addition of these two numbers. And thank you for using the calculator. Press any key. So now we finished handling the addition operation. Let's move on to the multiply operation. So to do the multiplication, we're going to use the same process of forming the first number and the second number, and instead of doing the addition operation on the two numbers, we'll just multiply the two numbers and view the result the same way we did in the addition process. So to save up our time, we'll take this stack and add it here to the multiply tag. We will do the same thing we did in the addition. We'll first give him the first message, enter first number, and then call input number, and then the second number, and the same way. Here is the difference. We have now the numbers in dx and the first number in bx and the second number in dx. So first, the multiplication process, expect that the first number in the multiplication is stored in ax and the second number is stored in bx, which we write after the multiply instruction. So first, after we have the two values in bx and dx, first of all we will move into ax the value of dx, and then we multiply here. We said multiply bx, which will multiply the value of bx into the value of ax, and the value will be, the result of this multiplication process will be stored in ax. So we move it into dx, and then push this dx to the stack, and then give him the message, the result, and we will view the result the same way we did in the addition process. Let's try this. We will run and say 2 multiply, enter first number 3 and enter 2, the result will be 6. So here is the result of the multiplication of these two numbers. So now we finished the multiplication. Let's do the subtract. We will also use the same procedure. Once you finish the first procedure, everything after that will be easy, because you will use the same function, the same procedures, the same way of forming the numbers. So come here to subtract, and we will form the two numbers the same way. The only difference here that instead of add, we'll say subtract. But we want to subtract the value of the first number from the second, the value of the second number from the first number. The first number is 3, the second number is 1, then 3 minus 1. And the value will be stored in bx, so we'll just move, or the result of the subtract operation will be stored in dx. So in bx, so we'll store it back into dx, and then push dx into the stack and do the same and view our result. Let's also try this. Okay, we are facing an error. Just the spelling. Okay, we will run and then subtract. We have 4, the first number, then 2. 4 minus 2 is equal to 2. Here is the result of the subtract of two numbers. Now let's do the final operation, which is the divide. We can take this multiply, it will help. And here in the divide, we'll do the same. Form the two numbers. We have the first number in bx and the second number stored in dx. But the calculation of the division process is a little bit different. We expect that the two values are in ax and ax or dx, and if you said divide cx, so he will divide ax by cx. We have our two values, so we'll just move bx into ax. We now have a fraction, the dividend and divisor. The first number should be in the upper part of the fraction, and the second number is in the lower part of the fraction. And the division process expect that the upper part is stored in AX and the lower part is stored in the register that you pass after writing the instruction. So we'll move the first number into AX and then move the second number is stored in the second number is stored into DX. I'm gonna move it into CX. Then move DX and 0. So, and instead of this you will have divide and divide CX. The quotient will be stored in AX and the remainder will be stored in DX. We will view the quotient, so we will move the value of the quotient, which is AX, into DX, and then push DX into the stack and do the same which we used to do in the other operations. But just keep in mind that this will get the result of a division of two numbers, and the result of division don't have a reminder. If it has a reminder, it won't be viewed. So for example, we have 4 divide 2, so the result will be 2. If we have any two numbers that the result of division has a reminder, it won't be viewed. So here's it, our simple calculator written in assembly language. I hope you find this video useful to start and write your first program. If you have any questions, don't hesitate to ask in the comments. Thank you for watching. See you in the next video.